Hello everyone, today I'm going to show you what is the Npsh available value calculation. This is a basic one, and as a mechanical engineer you have to know what is the difference between Npsh available value and Npsh required value. Basically this, if you want to select appropriate centrifugal pump for your system, you have to calculate what is the available value, Npsh available value. Then after the calculation, this Npsh available value, you can send this value to the pump brands. Pump brands, gives you what is the Npsh required value. They compare what is the Npsh available value, what is the required value, and then they can easily select for you this pump, and this pump's Npsh required value have to be this. So basically we have this example, calculate the maximum allowable Npsh required for the pump in the system. What we have on the system, you have to know this. If you want to calculate Npsh value, you have to focus on the suction line, not discharge line. So imagine here is we show you a tank, and elbows, a valve basically, but everything's in this suction line. So, and if you want to calculate Npsh available value, you have to know some information. What kind of information? For example, tank pressure, water temperature, or fluid temperature. I cannot say only water. Maybe your fluid can be changed, according to the system. So atmospheric pressure and the tank water tank level in the tank. So suction pipe, okay, and suction pipe length, elbow valves, and the volume flow rate. You have to know this information if you want to calculate the Npsh available value. And if you focus on here, what is the Npsh available value? Npsh available value consists of the static pressure head here. Static pressure head. What is the meaning static pressure head? Above the fluid in the reservoir expressed in meter. So, okay, what is the elevation difference from the level of fluid in the reservoir to center line of the pump suction inlet? And this value can be positive, this value can be negative. What is the condition? So if the pump is below the reservoir, this HS is positive. If the pump is above the reservoir, this HS is negative. You have to pay attention to this point. It can be positive, it can be negative. So what is the head loss in the suction piping due to friction? You have to calculate in this value. And what is the vapor pressure head? You can easily understand 4 parameters affect the Npsh value. Okay, let's get started to calculate this first static pressure head. Static pressure head, what is this? So you can see there, so our tank pressure minus 20 kilopascal. So but we have to calculate what is the absolute pressure. Absolute pressure meaning atmospheric pressure plus tank gauge pressure. Atmospheric pressure is 100 and the other one is minus 20 kilopascal. You will get this number for the absolute pressure. And what is the the gravity and density? You have to know here. This number comes from the gravity and density multiplying. So you know what is the gravity, you know what is the density of the flow. You can easily multiply these two value and write here. And then what is the elevation difference? Elevation difference, based on elevation of the tank, we have plus 2.5 meter. Why this is positive? Because imagine this is a centrifugal pump and there's a center line above this value. If this value lower than this, probably you will get this is a minus 2.5 meter. Okay, we easily calculate this value. And then what is the next? The next is the here head loss. If you want to calculate the head loss, you have to calculate the, velocity, Reynolds number, friction factor. So how can we, calculate the velocity? If you know the volume flow rate, and then we know the volume flow rate, what is it? And if you know the, cross-sectional area of the pipe, yes, we know, because the suction pipe is a DN40. So we can easily calculate here. How? And this is a 95 liter per minute, our volume flow rate value. So if you divide it by this value to the flow area, you can get 1.21 meter per second. Important things, the unit, this is a liter, this is a meter, meter per second. Please you attention this point. So where would you take this value? By using maybe a formula, or maybe you can use the table. Here is we have a table for this DN40 we have here. And what is the flow area? Flow area here, 1.314. Okay, you can write to here this number. And then finally you can calculate what is the velocity here. And what is the Reynolds number? So Reynolds number is very, very important for the fluid mechanics. So you have to know this. And how can we calculate this? If you know the velocity, if you know the diameter of the pipe, and if you know the kinematic viscosity or dynamic viscosity, it even doesn't matter. So these formulas, consist of kinematic viscosity. If you know velocity, we know here. And what is the diameter? We know the diameter is a DN40, and this unit is meter. Attention here again. 0.0409, this meter. And then what is the kinematic viscosity? According to the temperature, what is the temperature is 70 Celsius degree, and you can get the kinematic viscosity here, and you can write to here to calculate the Reynolds number. If your Reynolds number the higher than the 4000, this is a turbulent flow. And if your Reynolds number, between the 2300 and 4000, this is transitional flow. And if your Reynolds number lower than the 2300, this is laminar flow. We will say this. And then after this, and you have to know this ratio. What is this ratio? Diameter and roughness value. You have to know this. Why we have to know this? I will show you what is the reason. So what is the diameter? We know this. What is the roughness value? Roughness value here, a pipe roughness value. Roughness value directly depends on what is the material of the pipe. If your pipe is glass, if your pipe is plastic, if your pipe is steel, it can be changed. So our pipe material is steel, so we select the steel here. And what is the roughness value? Here. And we wrote there. So 2 value divided by 2 value, and you will get this. And this is our ratio. So what we calculate this value, okay? What we calculate this value, I will show you. This is our Moody chart. Moody chart is very important things, to calculate what is the friction factor, So we calculated the Reynolds number. What is it? What is the Reynolds number here? Sorry, here, our Reynolds number. And what is the relative roughness value? We calculate also here, relative roughness value. Then if you intersect these two value, and you will get 0.0225. This is our friction factor. Okay, this is our friction factor. So what is this? What is this whole formulas? These formulas meaning the head loss. If you want the head loss in the suction piping due to frictional, you have to know what is the friction factor. So we calculate there's a friction factor here. What is the length of the pipe, suction pipe? This is the length. We know this suction pipe length is 12 meter. And what is the diameter? We know, okay. What is the velocity? We calculated this here, we know. And what about the elbows? For the elbows here. And what about the valve? We know the valve also, and entrance. We have to calculate this attention point here. And we can write, common things, velocity squared divided by 2 multiplied gravity. This is common because here, and here, we can calculate this. This is a velocity hat. We can easily calculate this value. This is gravity, okay? And what is the velocity hat? This. You can write this formula to the here. And what is the friction factor? This. What is the length? What is the diameter? And what is the velocity hat? Plus here also. You could, write here. And you can, realize this 30 value and, 314 value here. Why? Because, the table 10.4, we use globe valve fully open. This is, this value comes from here, this table. This is a 90-degree standard elbow. Also, we used this. This is important things. Okay, we write here this number and this number according to the table. Okay, so we wrote what about the friction factor Ft. Comes from the Ft here for the elbows or the valve. Okay. You can look at the here 10.5, and for the DN40 you have a friction factor Ft this, okay, and you can write this to the formula. You will get this value. After all calculation, you will get the friction loss. What about this? 1.16 meter, okay. And finally, until now, we calculate what is the static pressure hat, and what is the elevation difference here, and what is what is the head loss, here. And final things we have to calculate. What is it? Vapor pressure hat here. And according to your fluid, according to your temperature, you have to know this information. So what is the temperature? 70. What is the vapor pressure at according to this temperature? 3.250. Okay, and then this is our pressure hat as a meter. Okay, and then what is the finally we know what is the static hat. Static hat 8.39 meter plus 2.5 meter comes from the elevation, okay, minus this. What is the minus? This is a head loss, okay. And what about the vapor pressure at? We calculate, we select from the table 3.25 meter, okay. What is the result? Result is this 6.48 meter. And as a mechanical engineer, you have to know this information. Your MPSH available value have to be higher than the MPSH required value. Minimum 10%. Minimum 10%. This is rule, okay? So you found this MPSH available value and you can get this value. Okay, why we calculate the MPSH available value? What is the reason? And you have to know, if you want to take precaution to prevent the cavitation problem in the pump, you have to calculate this MPSH value. If in your system, okay, MPSH available value higher than the MPSH required value, you cannot coming across the cavitation problem in the pump, but opposite side, if your available value lower than the required value, probably you will come across the cavitation problem in your system. Okay, thank you so much for your listening.